All right, so inequalities in a triangle. There's really only two kind of big rules that you need to know for this whole section, but they're super important. So let's just write them down so we've got them, and then I'm going to show you with the little model here. So big important thing number one, across from the biggest angle in a triangle, what do you think you're going to find across from the biggest angle? What do you think would be over there?
A smaller angle.
You're not wrong, right? I have the biggest angle. The other ones need to be smaller. But we're actually going to move from angle to sides. So what do you think has to be true about the side that's across from the biggest angle?
That both sides meet.
You're going to have the biggest side. So across from the biggest angle is going to be the biggest side.
Oh, that's what I meant.
Yeah. So just like when we're talking about the right triangle and we have the right angle and we know across from that right angle is always the hypotenuse and the hypotenuse is the biggest. So now I'm just saying any biggest angle, whether it's the 90-degree one, if it's an obtuse triangle, even if it's a cube, doesn't matter. Whoever is the biggest angle across from it is going to be the biggest side. All right. So across from the biggest angle in a triangle is the biggest side. So this is super important. It makes sense because we already knew that this was true in a right triangle. Okay. It does also work the other way around. So if I had the smallest side or the smallest angle across from that would be the smallest side. So I'll just add and across from the smallest angle is the smallest side. So what I want to do is I want to make a little triangle here and see if we actually agree with that. So give me just a second, find some colors that work out the way I want them to. And let me just switch this. Okay, so let's take a look at this triangle that I have right here. So the blue side, as you can see, is definitely the longest side out of the green, purple, and blue sides. So this one's my longest. And notice directly across from it, yeah, I have this big old angle. So that's not really a surprise because we already knew that in right triangles. So I'm going to have my biggest angle here. So we can clearly see that that angle is obtuse. So I know it's the biggest angle. Even I mean, I can pull out a protractor if you want me to, but there's no need. I can tell that that angle is bigger than 90. And so it has to be the biggest in the triangle because I can only have one angle that's bigger than 90, right? So there's definitely my biggest angle, and right across from it you see is the biggest side. And then let's turn our attention. We also said that across from the smallest side is going to be the smallest angle. So the green is certainly my smallest side of this triangle. And you'll notice the angle across from it. Yes, in fact, that is my smallest angle. If you're obviously that one's my biggest. And then I'm looking at these two, and you can certainly tell that this one's smaller. But if you were super curious, yes, this set does come with an attachable protractor. So if you have not yet filled out your wish list for stocking stuffers, you can always add these things. They're called Exploragons. I should get like a affiliate thing where like I make money if you buy them. You should buy them. They're so cool. Exploragons. Anyway, so yes, you can see that this angle looks like it's right about 25 degrees. So, and if you wanted to see this one, I'll just snap it on here. It's so cool. It snaps right on, so you know it's perfect every time. Oh, look, Ethan's joining us. Hold on. Ethan, hello. We're just looking at this angle, which is, oh, I don't know, what's that, 52? So certainly bigger. So yes, it's just confirming that across from my smallest side really is in fact my smallest angle. So pause for 1 second for me to update the attendance here. I don't know if I can do this without it breaking. Let's see what happens. I don't know. Ethan, let's see. Okay, I did it. Let's go back to, there we go. All right. So that was our major takeaway is that across from the biggest angle is the biggest side, across from the smallest angle is the smallest side. It also works if you start with the side. So I know that across from the side is the biggest side would be the biggest angle and vice versa, okay? Actually, if we want to just add that and vice versa, so then we don't have to write it again. Okay, so let's see if we can kind of put this together. I'm going to give you a triangle, and let's start off by, oh, what should we do first? Let's start off with, I'll give you the lengths of the sides, and then you tell me the angles from least to greatest. Okay, so let's do that. List the angles from least to greatest. Okay, so let's just do something like this. So I'm not going to give you any information on the angles. I'm just going to simply tell you the lengths of the three sides. So why don't I say this side is 8, this side is 9, and this side is 10. Okay, and let's say that we're in meters or whatever. All right, so watch how easy this is. If I need to list the angles from least to greatest, notice I have no idea what the measure of any of the angles are. I don't know. None of them are given. However, I know immediately that the smallest angle in this triangle has got to be what? Which of the three angles, A, B, or C, is the smallest?
A. B. A and B.
So remember what we said up top.
Oh, C. It's C.
Yes,
it's C.
Across from the shortest side is going to be the smallest angle. So my smallest side is this one that's 8. So across from it is angle C. So angle C has to be the smallest in my whole group. Does that make sense? So C
Yes.
is the smallest. Who's got to be the second smallest?
A.
A, yes, because 9 is my middle side, right? So across from that is this one here, A. And then my biggest angle's got to be
B.
B, of course, because that's across from the biggest side. I should put angle symbols in front of all these. Okay, does that kind of make sense? Is everybody with me? Because I'm gonna call on you for the next one. So make sure that you're paying attention and you're ready to answer me. Okay, I'm going to draw you a new triangle. We're going to do the same thing. Here's one other thing that I need to point out. You never, ever, ever go off of looks, right? Don't say, well, this looks like the smallest angle, so I'm going to go with it. You have to go off of the numbers. These look fine, right? It does look like C really is the smallest angle. And it does look like B is the largest angle. But I'm telling you, if I had changed the numbers around, you have to go off of the numbers, not the appearance. You with me? I hope so. So here, let me draw one that kind of looks like everybody's the same. Yeah. So now, I don't know. They all kind of look the same. So how would I know who's biggest, smallest, etc.? You're going to go off of the numbers. Okay, so let's try this. Again, we're going least to greatest. And let's say you are, I don't know. Let's say you're 14, you're 15, and you're 10. Who cares? All right, so let me get my popsicle sticks out here. And is this the one that's you guys? Yes, it is. Okay, let's see. Hope you're still with me and paying attention here. So what must be my smallest angle? Megan.
A.
I'm going to have to disagree with you. I want the smallest angle. So it's got to be across from the smallest side.
Oh, B.
Yes. B. So B is my smallest angle. Who is the next smallest after B? Kira is not here. Juliana, what would my next smallest angle be?
C.
You are correct. C. And then obviously my biggest angle in this case has got to be A because that's across from the biggest side. Okay, now I know what you're thinking. Mrs. Savia, what happens when you have an isosceles triangle and two of them are the same? Well, that's a great question. So if you had something like that, so let me just draw one of those real quick. If you had two sides the same, so let's A, B, C. So let's say these are both, I don't know, 4, and this one's 2. All you'd have to do, you're going to have, if you have two sides that are the same, aren't you going to have two angles that are the same? Right? Remember we learned that. So however many sides I have the same, that's how many angles I have the same. So I definitely know which angle is smallest here. Oh, there, because he's still in back. Okay, so which is my smallest angle, Colin? Colin, you there? I'm looking for the smallest angle here. Oh dear, Colin, did I lose you?
No, I'm thinking.
Which is my smallest angle?
Would it be C?
I'm not sure how that could be. Because across from the smallest side is the smallest angle. You're looking at the same diagram I am, right?
Yeah, it says 4, 4, 2, right?
Yeah. So, which is the smallest side?
2.
Right. So what angle is across from that?
A?
Yes, A. Okay, so A is my smallest angle.
Oh, wow, that was really simple.
Yes, I know. Which is why I'm confused. Anyway, now the other two, though, are tied. These two, because remember, if two sides are the same, two angles are the same. So you're going to have these base angles that are tied. So how you would write that, you would just say for the next one, B and C, sort of tied for this next place. So we'd say B and C. Okay, so if you ever had an isosceles, you have clearly a smaller one, and then these two are tied for the next largest. Okay, so now let's try and go the other way around. Now that we sort of have a handle on this, if I give you the side lengths, you can order the angles. But now, what if I gave you the angles and asked you to list the side lengths from least to greatest? Oh, let's take a look at that. So I've got to turn the page. So let's just flip this around. Okay, so now let's try this. So we're going to jot down our directions, list the sides from least to greatest. Okay, so I'm going to give you a triangle again. A, B, C, but this time I'm going to give you information about the angles and not the sides at all. So let's just say I had, oh, I don't know, let's make you an 80-degree angle. Let's make you a 60-degree angle, and let's make you a 40-degree angle. Okay, so I have my three angles. Hopefully you can see them nice and clearly. So now I want to list the sides from least to greatest. So which of these three sides, does anyone want to take a guess, has to be the smallest side? Anybody want to take a stab at this?
A
Oh.
and B.
Side AB, yes, because here's my smallest angle, the one that's marked 40. So the side across from it is going to be your smallest. So side AB, so remember we write that like this. So you're going to have AB with the line over it to indicate that it's a line segment, right? So there's that smallest side of my triangle. So what is the next smallest side after that one?
Side BC.
Yes, BC's got to come next. And then, of course, our largest side is going to be across from our largest angle. So here's 80. AC is the one we're looking at here. Remember, you can name the sides of the triangle either way. So if you said AC or CA, that doesn't matter because a line segment could be named either way. So you're not going to get it wrong. If you said CA instead of AC, same thing. All right, let's try another one. Be sure that you are ready to answer because I'm going to call on you at random. So be ready to unmute yourself here. All right, hang on. Let me get this image in there. There we go. So here we go again. Here's another triangle, ABC. And let's do the side, or the angles are, oh, I don't know. How about 20, 70, and 90. Okay, what must be my smallest side? And let's see whose popsicle stick gets called for this. The smallest side must be which one? Lyric, tell me.
What are you asking?
I want to know which of these three sides must be the smallest.
A.
Well, that's the smallest angle.
Oh, B.
Well, B's another angle. Side, if you take a look at how we just did one, right?
Okay.
So you need to give me a side.
Okay, AB.
Is the smallest?
Oh, I meant AC, sorry.
You want to try one more time?
BC.
Yes, across from the smallest angle, everybody, is going to be the smallest side. So since 20 is my smallest angle, that means the smallest side has to be BC. Okay, who is the next smallest side after BC? Hey, I'm skipping you, Haley, because you answered them all, so I know you know how to do it.
Oh, come
Chase.
on.
Sorry, Chase is not here though, so we'll go to the next one. Ethan.
Is it would it be CA?
No, because that's across from a 90-degree angle, right? So we already did the 20.
It would be AB. Yeah.
Yes, AB. So then clearly my biggest side has to be across from the biggest angle, that 90. So AC is going to be our winner. Okay, we're going to do one more of these. You guys are not going to get this wrong. I feel it. I know everyone's going to pay attention because once you get it, right, you're like, gosh, these are really not hard. But if you're not paying attention to me, class, I don't know how you're going to get them, right? So watch this. I am going to actually make this one a little bit harder. What if I told you this was 100 and this was, I don't know, 30. And that's all I gave you. Can you still order the 3 sides from least to greatest if that's all I give you?
Yeah.
Go ahead. Would you say yes?
Yeah, right.
I agree. Of course you can. Because even though I didn't tell you what this angle is, can't you just figure it out?
Yeah.
Of course you can. So all I ever really need to give you is just 2 angles because you can take a second and figure out what that third angle is. So I'm pretty sure on your homework, it's only going to give you 2 angles. Do not try to figure this out until you actually do the math to see what that angle is. Okay? Because sometimes you're going to try and do it in your head and it's going to be all wrong without finding this angle. Find the angle, I'm telling you. Here, it's super easy because I gave you easy numbers. So this angle has, of course, oh, wait. Why don't I call on someone to tell me what the measure of angle C is? Kaden, are you? I don't think Kaden was here today. Dylan, what must the measure of angle C be?
$40,
Close.
right? No.
If you told me your updated answer, I didn't hear you. But you are right that it's not 40. I don't know if I lost you or what, but the answer that I'm looking for is 50. Oh, okay. Yes, 50, right? Of course, because I got to add it to be 180. All right, now I've got those. So if you are,
That's what I thought at first. But I started to second guess myself because I thought that one had to be smaller than the other two based on just how you drew it. So that's why I didn't say 50.
yes, well, I said earlier, and I know you got kicked out at one point, but so you might have missed me saying this. You never, ever go off of looks. You just go off of the numbers. So even if it looks like it's a smaller angle, it doesn't matter. You go off of numbers. Nothing is ever drawn to scale. Okay, so yes, 50 was totally right. And then yes, you're right. It does look like it's supposed to be smaller, but we don't go off of looks. All right, so now that I have all 3 angles, I want the smallest side, which must be Elizabeth. Tell me what the smallest side is.
BC.
Yes, BC. It's across from the smallest angle. So I start off with BC, and then who comes next, Mark?
I'm just thinking really fast. AB.
Yes, AB, because it's across from the next biggest angle. And then, of course, that leaves our biggest side to be AC across from the biggest angle. The only one that's left. All right. So that's pretty much it for this first section. You know what? Why don't I do one of each real quick, and I'll let you do it all by yourself. And then if there's no questions, then I'm going to go ahead and try and get to exterior angles because they're pretty short too. And then you guys can have the rest of the time to just do the assignment and you'll be done for the weekend. All right, so real quick. List the angles from least to greatest. So we'll do one of those. And then I also want you to do one where you list the sides. Okay, so let's do this. Okay, I'll tell you this is 7, 8, 9. This is 50, 60. Okay, here are your two triangles. I want you to do these out. So the first one, you're finding the angles from least to greatest, and the second one, you're doing the sides. So take a minute, everybody. Get your answer for both of these. I may be calling on you at random in just a second. If you want to send me your answer, feel free to do that. Okay. Anybody? Oh, I got an answer. Let me see. Elizabeth, you sent it to everybody. Well, Elizabeth is correct for number 1. That's okay. That's fine. So let's double check and see if we all got this. So for the first one, you want to list the angles from least to greatest. So I want to start with the smallest side, right? Which is 7. So I got to see what angle is across from that. So that's why C is going to be my smallest angle of the 3. All right. Then the next smallest side is 8. So across from that is A. So it's got to go CA. And then it looks like B is going to be my biggest angle because it's across from the biggest side. So please double check that you have this one as CAB. Oh, wait. Oh my gosh. I didn't mean to list it like that. I need like commas between them all. They're all separate angles. It's not one angle CAB. What am I doing? Angle C, then angle, no, oh gosh. And it doesn't start with C? Oh yeah, it does. Oh my gosh, I'm losing it today. C, and then angle, what did we say came next? A, and then angle B. Ay, ay, ay. Whew. All right, there we go. So that should be the order for the first one. Angle C, angle A, angle B. The second one, ladies and gentlemen, I did not ask you to order the angles. You're going to list the sides So your answer should not be just angles for the second one. It's got to be side lengths, just like we did right here. See how we listed side lengths from least to greatest? That's what you're doing with this one. Sides from least to greatest. Now, you can't even begin this one until you figure out what the missing angle is. So I'm hopeful that you did that. If I have angles of 50 and 60, you need to take a minute and figure out what this angle is. Because remember, we can't go off of looks. We got to go off of the numbers. So if you don't have all the numbers, you can't do this. So let's see, 50 and 60 is 110. Take that away from 180. That means that angle up there has got to be, anybody have it? You should all have it. What is it?
70.
Thank you, 70. Now I can list the sides from least to greatest. All right, I still have a few of you here in my pile that I haven't called on yet. So what is my smallest side? James. Did you ever come on? I don't remember. I think you did. Are you here? Let me see. No, he is not here. Well, that's interesting. Okay, Vinny, are you still here? Oh, you are. Okay. What would be my smallest side?
BC.
Yes, because it's across from my smallest angle. Perfect. 50 is smallest. BC is got to be the smallest side. Okay, what comes next? Olivia. AC, you say, and nope. You have, so 50 is our smallest angle, so BC was our smallest side. The next smallest angle is 60, isn't it? So we want the side that's across from 60. Well, across from 60, here's 60. So across from it is side AB. AB's got to come next, which means that the only side left has to be our largest one, which makes sense because it's across from 70. The biggest angle would be AC. Okay. All right. So, yeah. All right. So now what I'm going to do is I'm going to try and talk to you about exterior angles. They are super fast. So I'm hoping to be done by 10, and then you can have that from 10 to the end to do the assignment, and then hopefully have nothing over the weekend. All right. So that's kind of my plan. So I apologize for doing 2 days worth in one, but with the snow day, we kind of have to make up for that day somewhere. So I'm going to jump right into 7-2, which is exterior angles. And I know the numbers aren't going in order. That's because I do this chapter out of order, because I think it makes more sense this way, but that's just me. All right, so we have talked a lot about interior angles of triangles, right? All three of them together add to be 180. Yeah, no big deal. Nothing like shocking about that. But check this out, okay? Watch this. I'm going to draw a triangle like this, where I basically have one side sort of extended. See that? So what I want you to do for a minute, this new angle that I created here is called an exterior angle. So if you just take one side of a triangle and just draw it longer, that angle you've created there is an exterior angle. So I want you to see if you can figure out the measure of that angle if I give you this information. Let's say that this is 20 and this is 100. So take a minute and see if you can figure out what the measure of that missing angle would be. If you want to send me your answer.
120.
Is it what?
Wait, do I have to put it in chat?
No, you can say it.
Is it 120?
It is 120. So my missing angle is 120. Now, hold on. So I got an answer. Someone else answered 60. 60 is the answer of the angle on the inside, right? Because think about it, the three angles inside of a triangle have to add up to 180. So I already have 120. So that's 120. So yeah, this one on the inside right here has to be 60. But I'm looking for the one on the outside. So here's what we know about the one on the outside. These two together make that straight line, don't they? So they have to add up to be 180. So if I do 180 minus 60, yes, I do in fact get 120 for that missing angle right there. I don't know how I want to do this. That one's got to be 120, right? However, maybe you noticed a shortcut here. Did you happen to know didn't we see 120 earlier in the problem? Look, it's just these two added together. Yeah, okay, well, that was just a fluke this one time, right? That wouldn't happen all the time. What if you had like a weirder looking triangle? That's not going to happen. Oh, well, let's try it. Will it not always happen? I don't know. What if I did some sort of super weird triangle like this? So same thing. I have a triangle with one side extended. I still want to figure out what this missing angle is out here. Okay, so let me give you the angles on the inside. Let's say this time this one's 110 and let's make this one 30. So go through the same steps again. So you could find the measure of this angle, and then these two again. These two are always going to add up to be 180, because remember how we're creating it. We're just taking one side and making it longer. So you're always going to have a straight line there. So these two have to add up to be 180. Right? So feel free to let me know when you have your answer for X. Yes, Elizabeth. Yes, Haley. Anybody else want to chime in? So I'm going to start the same way I always do, right? I'm just looking at the triangle. I have 110 and 30. So if I add those together, that's 140. Take it away from 180. That means 40, right? That's what's left. So this little angle right here has to be 40. And then if I remember, okay, well, these two together make a straight line. So they have to add to be 180. So if this is already 40, 40 away from 180, that means this one ends up being 140. So no way. This one on the outside is equal to the sum of these two. The two that it's not right next to. That's so cool. So you can actually bypass this whole angle. You don't even need to find it now that you know this rule. So the exterior angle is always equal to the sum of these two angles. Now they have special names. So I'm just going to explain that real quick. So this is really the only big takeaway that we need from this whole section. So put a big old star, and we're going to say the exterior angle, or I'm going to change it from the, because there's not only one. You could draw an exterior angle at each vertex. So let's just say an exterior of a triangle is equal to the sum. Now, these are really weird words I'm about to use, but I'm going to define it in a second. So we have a special vocab word for these two angles over here that are not right next to my exterior angle. They're called, they're called remote interior angles. So an exterior angle of a triangle is equal to the sum of its remote interior angles. And I'm going to put right here what though that means. So in other words, the two angles it is not right next to. That are in the triangle. Okay, so take a minute, finish writing that down. I am pulling up the assignment for today. So you are going to have two of them. I know, oh my gosh. But if you have been paying attention to me, I promise you that they are super fast. And really not too tough either. Does anybody have any questions right now? No? All right. So let me